Hello students, I am Mr. Adinath D. Badar, Assistant Professor, Department of Chemistry, late Pushpadevi Patil, Arts and Science College, Risod, Dist, Washim. In the last video lecture, we will discuss what is meant by ionic bond. What is meant by ionic bond? So, we all of know the ionic bond nothing but the simple electrostatic attraction between positive cation and negative anion. Now in this video lecture we just discuss Born-Haber cycle, that is the formation of sodium chloride molecule or formation of ionic bond. So firstly we discuss of what is mean of lattice enthalpy or lattice enthalpy. What do we mean by lattice enthalpy? For an ionic compound, the lattice enthalpy is the enthalpy change when 1 mole of solid is started state is formed from its own ion in the gaseous state. The lattice energy cannot be measured directly, and so we make use of other known enthalpies and link them together with the enthalpy cycle. So this enthalpy cycle is the Born-Haber cycle. The lattice energy of an ionic solid like sodium chloride, that is NaCl, may be determined by using Born-Haber cycle. It is a thermochemical cycle and was devised by Born and Haber scientists in 1990. The cycle first relates the lattice energy of crystalline solid to other known thermochemical quantities. Then it makes the use of his law to evaluate this unknown quantity of all the linked step. So we will discuss Born-Haber cycle in this lecture by step. So first step is sublimation of sodium. First step is sublimation of sodium. In this process, 1 mole of sodium solid state change to gaseous sodium. The energy required for this process is denoted by Hs, that is sublimation energy of sodium, heat of sublimation of sodium, and its value is experimentally found out to be 107 kilojoule per mole. These are the first step of Born-Haber cycle, that is sublimation of sodium. So simple conversion of solid state sodium into the gaseous state sodium. This is the first step of Born-Haber cycle. So now we will discuss the second step involved in Born-Haber cycle, that is the bond dissociation of chlorine or dissociation of chlorine. In this process, half mole of chlorine is dissociated into 1 mole of chlorine atom. Here these are the chlorine molecule is converted into atomic state, that is Clg. These are the Cl2. These are molecule. These molecule are converted into atomic state, and this process is called as dissociation of chlorine or bond dissociation of chlorine. The energy required for this process is 1 half d 1 half hd is plus 121 kilojoule per mole. This process required this amount of energy, that is positive energy, 121 kilojoule per mole. Now the third step is ionization of sodium, or simply we can say formation of sodium ion. In this process the gaseous state, sodium atom is converted into ionic state, that is, it carries a charge by loss of electron. 1 mole of gaseous sodium, 1 mole of gaseous sodium atom are converted into sodium ion by removal of electron from each them. Energy required for this process is ionization energy of sodium, is called ionization energy of sodium, and its experimental value is 502 kilojoule per mole, and it is denoted by del Hi, that is ionization energy for sodium. So in this step, simple, the atomic state sodium is converted into ionic state, that is Na is converted into Na plus, simply Na is converted into Na plus by loss of electron to give ionic state. Now the fourth step is formation of chloride ion, or simply we can say conversion of atomic state chlorine to the ionic state chlorine by gaining a electron. 1 mole of chlorine atom form in step second is converted by taking up one electron provided by sodium to negatively charged chloride ion. The process is accompanied by release of energy, and this process is a energy release process, and it is also called as exothermic process. By definition, the energy released in this process is electron affinity of chlorine. Its experimental value is 300 355 kilojoule per mole, and it is denoted by minus or negative sign. Due to this energy is not required, these energy are released, that is exothermic process. So simple, in this process one chlorine gaseous atom is converted into chloride atom, that is Cl is converted into Cl minus by loss of electron, and this step is exothermic, that is loss of electron. Now the next step is formation of ionic crystal, that is NaCl, formation of NaCl, gaseous sodium atom and chloride ion form in step number 3 and step number 4 above combine to give a solid sodium chloride crystal, that is Na plus Cl minus. Energy is released in this process also, and by definition this is the lattice energy of NaCl. It is represented by that is del Hf, that is formation energy or lattice energy is minus 411 kilojoule per mole, and this step is also exothermic process due to formation of sodium chloride. These steps are exothermic or energy release process. Now the last step, that is lattice enthalpy for sodium chloride. In this step, 1 mole of sodium ion plus 1 mole of chlorine ion attract electrostatically to each other to give NaCl solid, and the amount of energy is released, and this energy is called as lattice energy or lattice enthalpy, and it is denoted by del HL is equal to minus 786 kilojoule per mole. And in this step, the sodium chloride molecule, that is NaCl, is formed, and these are the last step of Born-Haber cycle for the formation of sodium chloride molecule. Now we will see the diagrammatically Born-Haber cycle, that is these are the first step, that is sublimation of solid sodium into the gaseous sodium. These are the first step, that is Na, that is in solid state, is converted into sodium in gaseous state. These are the sublimation process of sodium, that is Sna is equal to energy required, that is 108.7 kilojoule per mole. Now these are the second step, that is dissociation of chlorine. Half mole of chlorine molecule is converted into atomic state, that is chloride state. These are the dissociation of half mole of chlorine gas to the chlorine atomic state. Here molecule is converted into atomic state, and energy also required, that is 112.95 kilojoule per mole energy required. These are the step first, that is sublimation, and these are the step second, that is dissociation of chloride. Now the third step, that is formation of sodium ion, and these are the ionization of sodium. In this step, the gaseous sodium is converted into ionic state, that is atomic sodium is converted into ionic state by gaining a amount of energy, that is 489.5 kilojoule per mole energy is required. Now these are the fourth step, that is formation of chloride ion. Formation of chloride ion. Here the chlorine atom gain electron donated by sodium to convert gaseous chlorine to the gaseous chloride, that is here neutral chlorine are converted into ionic state, that is negative state, and this is called chloride ion. So up to the fourth step, step number first, second, third and fourth, the Cl minus is formed and sodium plus is formed. This sodium is formed by loss of electron, and this lost electron are gained by Cl. It also converts into Cl minus. Now the last step, that is formation of sodium chloride. Formation of sodium chloride or formation of ionic bond. So simple electrostatic attraction between this Cl negative and this Na positive to form NaCl solid molecule. NaCl solid molecule, and in this step the amount of energy is released, and this energy is called as lattice energy. This energy is called lattice energy, and the whole process or whole cycle is called Born-Haber cycle for the formation of ionic solid. Or here just we take the example of sodium chloride. So simply we can say Born-Haber cycle for the formation of sodium chloride. This type or this side are denoted by stepwise formation of NaCl, and in the left side here direct formation of NaCl, direct combination of sodium solid and half chlorine molecule to give NaCl, and heat of formation is equal to 414.2 kilojoule mole inverse. So student, in university exam the compulsory questions are asked on this cycle for the 4 marks. So keep in